Alright, welcome back to Meteorology 101. This video, I'm just going to hit the charts, maybe hit some radar, check out the system that moved through. Got a frontal boundary pretty much pushing through the Midwest all the way down into Texas. And then that low pressure system that we looked at a few days ago that was over eastern Colorado has shot to the northeast. So that's what developed this frontal system. You can pretty much see that boundary right there through all the way through Ohio, Missouri, Arkansas, all the way down into Texas. Then we have some pretty significant weather in Texas. It looks like some build up there, and then southern Illinois up in the northeast. So we'll break this down, look at it for a little bit, and see where this goes. So I'm going to start with the surface pressure, identify highs and lows. Like I said, we knew that low pressure system was over eastern Colorado. That pushed off to the northeast over the Great Lakes region. High pressure's pushing in, so that's the leading edge of the cold air mass, that frontal boundary. This is pretty elongated with this low pressure system tying into that low. There's a little bit of extrapolation going on there with the charts, so we'll have to see what's going on there. Probably just a little bit of ridging, just something to separate these two systems. So typically if you get a cold front pushing all the way down into Texas, you can actually get a low pressure system form up on that front. As it becomes stationary, starts to stall out, get another low form up on that and push to the northeast also. Not sure what's happening there yet, but we'll look at the radar, we'll check out the model, see what's going on. So this low pressure system was over Mexico a few days ago. It's basically just like a heat low just sitting there. Rotation around the low pressure is counterclockwise, so we're getting the moisture from the south, the warm moist air. We'll look at temperatures, dew points, try to see what type of boundary is right there, maybe some warm air advection. Let's go ahead and throw the isotherms on here so we can see where any advection is. So we do have a little bit of warm air advection in that area. It's pretty weak, but it is there. So you could put maybe a little cold, warm front coming out of that. Not much advection going on to the west. So low pressure that pushed off to the northeast. It's probably an occluded low, bringing it an occlusion down and a frontal boundary all the way down to the west. Let's clear this out real quick. I want to put pressure on here with no highs and lows because we'll add the fronts. See how cluttered that gets. Without the highs and lows, it keeps it to a minimum anyway. Because the front, when I put the fronts on the charts, it puts highs and lows with it. So if I have highs and lows labeled already, then it puts more highs and lows and it gets really cluttered. You'll see here in a minute how bad this gets. So if we put the frontal boundaries, see how all these highs and lows or troughs, everything just kind of clutters together because these computers are not very good with these frontal boundaries. So you got to put the data on these charts. Let's go ahead and do that, and then you can verify where these fronts are. There's your occlusion. Low pressure system well to the north. Looks like this high pressure out here over the Atlantic is blocking this warm air, the lower pressure. So that's why that warm front's kind of wrapping around that high. I'd say there's a subtropical high to the east over the Atlantic, and that's kind of ridging in to the southeast. You get a little bit of a few minor short waves pushing through that area, but you're mostly clear skies in the southeast right now. Southern Texas, Florida looks like it's broken. Got a easterly flow, 5 knots, onshore flow. Really nothing significant there, but you have a little minor short wave right in that area and causing some instability. We got troughing out of the low. Like I said, you could probably put a little bit of a warm front right there, but maybe just an inverted trough. But there's the leading edge of the air mass, the high pressure system, and it looks like a low. That frontal boundary becomes stationary, obviously between these two highs, and then maybe a low right there. Let's look at the rotation on that real quick. I can see really not much rotation. We got a little bit of low level convergence, so that would be causing maybe a little bit of surface pressure drop that would cause these computers to put a low right there. So minor short waves. This high pressure system looks pretty much barotropic high. So it's highly modified. Look at all the moisture throughout the center of that high. If that was a really strong high pressure system, you'd pretty much have clear skies all throughout the center of that high. Alright, so we got the fronts on there. Everything's good to go. We got the boundary pushing through. That's what's causing all this, the lift that along with this unstable air mass, and causing all these thunderstorms along that frontal boundary. So let's I don't really want to go up to the upper levels too much right now. Let's just go over to the radar and we'll start breaking down some of these cells. We'll see where our severe weather is, and then we can actually break down the cells a little bit more and see what's going on inside. Alright, so we're starting off in the northeast. I see flash flooding. Let me put my warnings window. You may not be able to see it. Only show certain windows at a time. So up in New Jersey, there's several flash flood warnings. There's a flash flood warning in Oklahoma. And we have severe weather thunderstorm warnings. We got 4 warnings in Texas. So we'll shoot down there next. But we do have some pretty heavy rain right through here. Trying to see where that is. Pennsylvania. So you get up into Jersey, you get the flash flooding, and that is Doppler radar indicated thunderstorms producing heavy rain across the warned area, between 2 and 3 inches of rain. So that's what the justifies that those flash flood warnings. So we got I got live station plots on here. The latest station reports, observation reports. So I got a window that pops up each time I get over one of these stations reporting, like this one, Morristown. This is reporting heavy rain, thunderstorms, 2 miles visibility, overcast 700 feet. So the base of the thunderstorm is at 700 feet. Temperature and dew point are both 16. We're 100% saturated. Winds are calm. IFR conditions, because we're visibility is below 30 miles. Alright. North of Caldwell. See if this shows the city. It says the site is Caldwell. Nearby thunderstorm, overcast 700 feet. Visibility unrestricted. But ceiling is below 1,000 feet, so we're still IFR conditions. Winds west-southwest at 3 miles per hour. So really not too windy out there. So we do have the rain. They're reporting thunderstorms in these areas, but I don't see any cells to indicate those thunderstorms. We are on the base level of base reflectivity. We'll go into the upper levels of that radar, and you can see everything just disappears. So these storms aren't extending up very high at all. If we go echo tops, we don't really see any echo tops in that area until we get over to the west. So up by Hamburg, now we got echo tops 32,000 feet. Base velocity, I don't see any rotation. Find our radar sites right there. KCCX. This is State College, Pennsylvania. So the winds are pretty much from the west to east, southeast. So there's really no rotation in any of these areas to be concerned about severe weather. Let's go down to Texas and pull up one of these warnings. Pull up a radar site down there. Here's 4 different warnings in Texas. Up near the Panhandle, in northern Texas. We got winds out of the east northeast, 9 knots gusting to 15. Mostly cloudy, broken 11,000 feet. Alright, so let's go to these cells. We got a little hook echo right there. So So we have to keep an eye on it. Let's go ahead and do a cross section on that. Break that one down. It's pretty good vertical development. Still pretty vertical though. Slight tilt on that storm, so definitely does justify severe. Let's go see if we can get back into that hook a little bit. I think we're pretty much there. Let's move this around. We can adjust to our highest reflectivities. I mean, we got 50 dBz, 52.5 dBz all the way up to 40,000 feet. So that's a pretty severe cell right there. That updraft's pretty strong. I don't see any 60 or higher dBz reflectivity to indicate major hail. And I don't see any hail symbols. There's one right there. We got a 0.87 inch hail right there in that area. So we are in the severe criteria. 3/4 of an inch is severe. So we're just above that. So if we do a volume scan on that one, now we can pull it up into 3D. And this is 50 dBz or higher. So we can change that. Go up to 60. There's no 60. That's all 50. 50 to 59. Now you do have pretty good shape on that thing. Let's go back down to the lower reflectivities and we get the outer shape of that storm. And then you can see our overshooting tops, well over 50,000 feet. Alright, there's the lowest reflectivity we can get to. And that's pretty much the shape of that storm. Let me go get a little bit better, wider shot of that one. See if I can get outside of that, kind of get that centered on that screen. A little hard to do sometimes because what you're actually doing a volume scan on is a little bit different from what you see on the screen. The screen's the updated image, but the volume scan is sometimes a couple images behind. Let's do that again. What do we got going on here? What, did I close it out? Alright, let's get back open. Hold on just a second. Alright, go back to Texas. Right here, let it download again. It doesn't really save any data. Alright, I don't see that hook where we were. Here's 0.83 inches right there. They don't even have a severe warning right there. Let's go do a volume scan on that. Go bigger. Alright, there's the complete cell right there. We are cutting off the edge. Let's try this again. Still looks like we're cutting it off, or we're just losing that. That's pretty much it right there. We're just going to go for that one. We're up above 40,000 feet, overshooting tops on that storm. I said you can see the outline. That's just the lower DBZ, lower reflectivities. Then you go to the center to the high reflectivities, and you can start seeing what the shape of that updraft. Right there, it's a pretty good updraft, up to 30,000 feet. Once you hit 50 dBz, that's where you go severe. Anything 50 dBz above 10,000 feet is a potential for severe. Let me get out of that real quick. Let me go back in. Alright, what do we do here? Okay. Alright, there we go. So that's a pretty good updraft. See if we got it to a 60. We made it to 60 on that cell. Below 10,000 feet. So there's your higher reflectivities. Maybe Not really any debris or anything, but maybe some hail forming. But you're below 10,000 feet, so I think your freezing level would be above that. You should have been the hail should have been a little bit higher, but you're getting heavy, very heavy rain for that high reflectivities right there. All right, so let's go back over here. We got 1 inch hail, so 1.8 inches. That's just below 2 inches of hail right there. So let's do a cross section on that real quick. Let me go to a different angle and see if we can. It's pretty vertical on that. There's really no major tilt. But we do have 70 dBz reflectivity within that storm, so you definitely got some pretty heavy hail there. Like I said, it was just below 2 inches. So now let's do a volume scan on that one. That is a high reflectivity from hail right there. That's all hail. The center of that storm. Let's go break that one down to lower reflectivity. See how high that goes. Jumped off the chart. Alright. So overshooting tops on that one, just over 40,000 feet, almost 50. Now, bring that one down. Pretty isolated cell, but it's very, very strong. So let's do a base velocity on that one. Alright, now you can definitely see ins and outs of the radar. You got rotation. Let's go look at rotation real quick. So you can definitely see you got rotation through that storm. So justifies severe. I'm surprised they didn't do like it might be a tornado watch in that area, but I'm surprised they didn't do a tornado warning just based on rotation. You can do another volume. Let's go back to base reflectivity. Let's go back to the base velocity. Alright, let's run that down. Go to higher wind speeds. Once you get down into a little bit lower wind speeds, like about what, 20 knots. You can definitely see you have rotation in that area. So let's go look at the 2D on that one. So definitely have rotation right there with 1.8 inch hail. So I don't know why they're not going tornado on that one. Alright, we're going to do a volume scan. Let's get rid of that. Drag this over. Go back into these other warnings. So we're on the outer edge of this radar. So it looks like we do have rotation right there too. Let's get to see if we can go. Here's Frederick, Oklahoma radar. Let it download, see what we got there. So radar's to the north. I don't really see. We got the greens are in toward the radar, reds are out. 1.07 inch hail. Do a cross section on that one just to see. Another cross section. Let's go over here across that hook right there. So you can see that pretty vertical. Start looking for more tilt and then watch for that tail to come down. You can see a vortex, but let's go let's do a volume scan on that one. There's our 50 dBz or higher. We're all the way up to 40,000 feet. And you can see definitely the overshooting tops on this one. It's pretty much going to go well above the chart. So you're above 60,000 on that one. So that's a pretty severe storm. That's pretty much it there. Let's go make sure we don't have any other warnings. We've got Oklahoma, flash flood. Thunderstorms being reported. Let's look over. These are all thunderstorms right in that area being reported by all those stations. Alright, let me go to see if we can pull up the models. I don't know why you can't see them. Let's go. Get this reset. Alright, it's 21Z Wednesday, a little bit behind, a few hours behind. We see a low pressure system to the north. Let's see what that does. There's your high in the center U.S. You actually, there's that tropical storm we were talking about a few days ago, coming out of the Yucatan. That's a possible tropical disturbance there. We'll see where that goes and if that's going to hit land. So the high pressure pushes off over the east coast. Does look like a pretty significant storm, possibly becoming a tropical storm. Hits southern Florida. That could change though. But we're only. This is 12Z on Sunday, so actually making landfall about 15Z on Saturday. So we're only a few days out on that. So that could still be very, very possible. And then just this high pressure system was at a plateau high. Minor short waves all around that. All the precipitation up in the northwest. And that storm over there kind of just lingers around and finally pushes off into the Atlantic. So what do we got up here to the north? Watch this cell right here for the low pressure system. Kind of just develops right there to the north and it starts pushing to the east northeast right over the Great Lakes region. So probably have another frontal boundary that looks like higher pressure behind it. So another frontal boundary pushing through. And then maybe another low pressure system right here coming out of the panhandle of Texas and then pushing to the northeast and then bringing that frontal boundary further south. Where does this high come from? So that high pushes out of the northeast, drops down, clears everything out, and then pushes off to the east itself. But you have another system up to the north over the Great Lakes region, drops out of like Saskatchewan, Canada, pushes that south over the Great Lakes region, kind of like a clipper system pushing through. Another frontal boundary, plateau high. It's pretty far out though. You're 345 hours out, so I wouldn't take this. I'd take it with a grain of salt, but looks like another disturbance down south, just kind of sitting there though. That's way out there though, so we won't worry about that. If I loop this thing, get where we can see the scroll bar. So there's the beginning right there. So we'll just loop this. If you see those systems just pushing through, you can see those low pressures just rotate and just keep pushing through. Well, to the north, some of them don't even make it. They just shoot up to the north, right back up into Canada. But you look at that system, that tropical disturbance that shoots across Florida. It looks like a pretty decent system. Want to see what the National Hurricane Center says on that in the next couple days. All right, let's jump to a maybe do a satellite real quick. See what Storm Prediction Center. Let's see. There's a satellite. You can see significant convection over Texas, all along that frontal boundary. That's where you're getting all the thunderstorms, heavy precip. Pretty clear in the southeast. There's a little bit of that disturbance down south. That's just maybe a that's just your tropical thunderstorms. It's really not really a system there. I don't see any rotation. Just your air mass thunderstorm stuff from daytime heating. Daytime heating playing a big role in most of this. There's your high pressure system. There's your ridge. There's the cirrus spilling over the ridge. Look like you have to get another shot up to the north to see where the rotation of that low is. But this is just more or less a boundary that's become a, with that low pressure system pushing to the northeast, just become a real slow moving boundary. And then another, looks like high pressure over around the Four Corners area, Southern California, and you got that spill over that ridge. So alright, that's it. Let's go back. We'll hit some charts real quick. I'm almost half hour in, so try to keep this short and sweet. But let's go. Let's pull 500 real quick. It's 500 millibar chart. Actually, this is going to look cluttered because it puts this green over top of this radar, so it gets pretty nasty looking sometimes. That's not too bad. Shows where the moisture is at 500 millibar. Still got moisture over Texas. That's not coloring in. You don't have moisture over Oklahoma. I'm sorry, Arkansas, Oklahoma, Missouri. So that hit pretty decent there. So let's go. Let's pull a vorticity chart real quick. Actually, that's not going to look good at all on here. So let's get rid of this. Let's go to let's recenter our map. Clear everything off. Alright, right there now. Now let's run the 500. You see most of the positive vorticities to the north, pretty much where that low pressure system was, and then that frontal boundary, is really not much going on there. So all this stuff, we had them severe storms in Texas. Probably not going to look at tornadoes just because you got negative vorticity there. The rotation's just pretty much holding that back. It's just not real significant in those storms. So let's go to look up a stability chart. See where potential areas for severe weather would be. And you can see over Missouri would be it's pretty weak, but then the northeast, Connecticut, that's where your most significant area for severe weather. So as that frontal system pushes to the east, I wouldn't be surprised to be more severe storm warnings put over there. do a lapse rates real quick. So our significant lapse rates is down with that low pressure system is over Mexico of 8. As you're looking for 8 or higher. I mean, 7's unstable, but it's 6.7 is normal for the lapse rate. That's your temperature change with height. So 6.5, 6.7 degrees per 1,000 meters is standard atmosphere. The standard lapse rate, how much the temperature drops as you go up. So 8, once you start getting 8 degrees, that's where you start looking at possible severe weather. So you go back to that satellite, you'd see where that significant weather is down there right along the Texas-Mexico border. Let's see, right there. Alright, let's see what else we can run. Do that total index. That thing hit it pretty good the other day. Man, that's the area instability right there. The most you're looking for a 50 or higher, so we're at 48. So it's pretty significant. Pretty much right along that frontal boundary. That's where all the instability is. So as that front pushes south to southeast, that's where you're going to continue with the rain, thunderstorms, possible. Some areas of possible severe weather. So. Alright, let's see. And low level wind shear. You can't have tornadoes without low level wind shear. You're looking for that low level jet. You really don't have it here, so. Pretty much answer that question why we haven't seen any tornado warnings or anything like that. So we just don't have the low level jet. If we pull an 850 real quick, go to 5,000 feet. Pull that chart real quick. So we got the high pressure dominating at 5,000 feet in the southeast. That's where pretty much clear skies. Got that warm core low down over Mexico. You can see that with the isotherms. And then with the station plots, we can see moisture over Florida, moisture at 5,000 feet over Alabama, Missouri, Kansas, the panhandle of Texas, and Illinois. So I mean, these are pretty scattered because these are just balloons that are let go. The radiosondes are done every 12 hours, so a lot of that data is pretty sparse anyway. But we are saturated in these areas. Anywhere you see the black station plot, we are saturated. So looking at the wind speeds, though, you're 15 knots. It's like 15 to 17. Here's a 20 over the panhandle of Texas. It's the most I see. Right there's one in Pennsylvania, 20 knots. 25 right there over New York, Buffalo, New York, I think that is. That's pretty much it. So you need about a 40 knot wind to have low level wind shear. At least 40 knots, get a low level jet. Bring that down to 5,000 feet. And then you could look at getting the exhaust system you need for the severe weather for the tornadoes. Alright, so that's what I said. We don't see it. We're dominated by high pressure in the southeast. We got that low pressure system. It's a warm core system, pretty significant inverted trough, stacked vertically. It's just a warm core low over Mexico. So if we go to 700 real quick, pull the pressure on that. Then we'll see it again. See how high this thing goes. This goes up to it's about 10,000 feet on that 700. So now you see high pressure in the upper level starting to ridge over toward that. We do have that inverted trough. It's still troughing in that area. Let's go look at our temperatures. Now we got thermal ridging, so our temperatures are reaching that height, but it's not closed off for that core, that warm core system. So once we hit about 10,000 feet, this thing starts to weaken a little bit. Go back to that 500. And you won't even see, probably won't even see the trough. Now we got high pressure in the upper levels. So we got the heat low, bringing upward vertical motion, creating the pressure on the tropopause and causing a high pressure. That's why it's a vertically stacked barotropic low, warm core low, and pushing that pressure up to create high pressure in the upper levels. Just like a hurricane would. You'll see low pressure on the surface, high pressure in the upper levels. So we still got some thermal ridging, nothing closed off. And we always want to look at the jet stream, so let's go poor wind shading. Pull front jet well to the north, pretty zonal. You can see that ridge. That's where that Sirius was spilling over that ridge. That jet max moving out of the ridge. That ridge is going to weaken. Now we got so it's isotherms. There's some pressure. Station plots. So we pretty much don't have anything down here in the south supporting that low. Nothing sucking the mass out of that. That's why the pressure is building. It's a vertically stacked low, running pressure all the way up to the tropopause, and then just pushing pressure, creating that pressure in the middle of the upper levels. Alright, so that's the jet stream. Like I said, well to the north, supports that frontal boundary. But that low pressure system is well to the north. This jet is cutting through the low and then just pretty much stalling out. And that's why I said that front is pretty weak and a slow moving front. So, alright, that's pretty much it for now. I'm gonna hit the books. I think next time. I think I'm gonna cover we'll start with the basics. We'll cover atmosphere. I've got other videos on the atmosphere, layers of the atmosphere, stuff like that. I'd like to do something on like the Hadley-Farrell cells, the atmospheric rotation. Maybe do like do those cells, and then what type of clouds and what areas and where the jet streams are associated with those cells, and show how those jet streams are formed with a north-south temperature gradient, and then based on those pressures with those low pressure at the equator, your 30-degree latitude, 60-degree latitude, 90 degrees. Look at the pressure systems overall for atmospheric circulation. Once you understand atmospheric circulation in the jet stream, then you can see how you get lows and highs that form off of those as semi-permanent high pressure systems, low pressure systems, and then you can start developing your weather patterns from there. So give me a little bit of time. We'll start getting into the books instead of just chasing the models and chasing the charts. I mean, I don't mind doing that. Just current events with the weather, what's happening now. We could break down those storms and look at them on radar, do the cross sections. That's all pretty cool. But once you understand atmospheric dynamics and the fundamentals of that, then you can start pinpointing these things and start really writing forecasts. So I want to say thanks for watching. Visit my website, meteorology101.com. A lot of information on that. A lot of stuff might be over a lot of people's head. I'm going to try to simplify that site a little bit when I get some time, but I think I'll just do most of this through video. So hit the thumbs up for me. Give me a little bit of ratings, and until next time, get your head in the clouds.